initial kinetic energy is 8 times 10 to the 7th. And then the initial potential energy will be negative G big M small m R. And the final will be G big M small m divided by R prime, the final radius. So, and then we know the initial is, we want to get this number. This number we don't know. We know all the other numbers. So what we need to do is plug in the numbers. And here is 6.67 times 10 to the negative 11 times 4 times 10 to the 23 times 10 divided by R. R is 2 times 10 to the 6. So if you calculate this side is a calculator, you can get 5.34 times 10 to the 7th. Okay? It's negative. So it's negative 6.67 times 10 to the 11 times 4 times 10 to the 23rd times 10 divided by the final R. So you can put positive here. Okay? It's negative in both sides. And then you move this here and then use this number, divide by this number. That will be the final radius. So the distance from the center of the planet will be, if you calculate this, is 4.996 times 10 to the 6. So the answer will be D. Okay. 4 to 6 is the same formula. You need to use conservation of the energy. So you understand one, you understand all of them. Number 7, 2 satellites. 2 satellites. They're in the same orbit. Okay, they're in the same orbit with the same period. It's 24 hours. Okay, with a period of 24 hours.
I can't really see it
The circle.
on the camera. Yeah.
So there are 2 satellites. Okay, they're on the same orbit essentially, and we know this B, this is A, this is B, for example. This B, for example, A is M, B is 3M. 3 times the mass of satellite A. Okay. What we know is, and the question is, what's the relationship of the gravitational force, Fb and Fa. So we know F is equal to V squared R times M, right? V squared is if you calculate R times M divided by T squared. That's what we did for the second question, right? And they share the same, the 2 satellites. They have the same period. For pi, the same R is the same. They're in the same orbit. So the only different thing is M. So Fa will be 4 pi square R times M divided by T squared. Fb will be 4 pi square R T squared times 3M, because Fb is 3M, 3 times the mass of A. So essentially you can get Fb 3 times Fa. right? Because the only thing changed is the mass 3 times. So the force is 3 times of Fa. So the thing is, you need to get this formula, which we already talked about for question 2. So for 7 is D. F D is equal to 3 times Fa. The last 2 is very easy. So it's about for example, the Earth and the Sun. The Sun is here and the Earth go like this, right? Because that's counter clockwise direction. Okay. So you can study some side. We can talk about some. Basically, these 2 questions is more conceptual questions. So here is really far, right? Here is more close to the sun. If it's far, but the energy it conserved is always the same, because it's a whole system. The energy will be the same. And another thing is the circular momentum is the same, right? So here it has the energy is contained by potential energy and the kinetic energy, right? Here is really high, so it has more potential energy, right? If it has more potential